Okay, the next time we're going to talk about air fuel formation. Carburetors, back in the day carburetors. Now we got fuel injection, mechanical, electronic fuel injection systems. Here's a dissected carburetor overview of the different carburetor components, or parts I should say, exploded view of it. You got the air horn, gaskets, main body, the throttle body, sorry, the main body, the lower, I forgot the name of the section, it's been so long, the throttle body section, and the gasket between the body. Now, don't worry on the test, you don't need to identify these parts, but you will need to know what they do. Let me see, you got the float right here, air horn gasket, what do you got? Air fuel mixture screws. They're going to ask you about the air fuel mixture, the choke that's in the air horn, the float. What else are they going to ask you about? They're going to ask you about the, I don't see it, accelerator pump here, the power circuit. Anyway, we're going to go over all this anyway. Here is a parts of the fuel system. You got the carburetor, you got the throttle plate, and idle screw on carburetors. You have to check, it's called a base idle. On carburetors, they have a screw adjustment for it, unlike fuel injection, at least some of them anyway. You got the choke plate here. And I want to talk about this, the idle fuel mixture screw. Now, sometimes a car will run rough, and it's due to the air fuel mixture, either too rich or too lean. Here's an example. If the car is running rough, and what we used to do is, we should, like say this is the carburetor, we should take our hand and put it over the carburetor choke. If it's smoothed out, we know the car is running lean. We know it's running lean. If the car is running rough and you made a vacuum leak and it's smoothed out, we knew the car is running rich. So back in the day, what we used to do is adjust the air fuel mixture screws. If that didn't help, we either had to find a vacuum leak or go internally inside the carburetor and clean a port out, see if it had a bad flow or a bad gasket or plugged air bleed. At the basis of the air fuel mixture, a rich condition or a lean condition. Again, if it's running rich, if I make a vacuum leak, the car will smooth out. So I knew I needed to figure out why it's running rich. Like for example, that I would have to turn the screw in to lean it out. And rich means too much fuel also. If it was running lean, and I put my hand over the choke or add a propane to it and smooth out, I had to find a vacuum leak or turn the screw out counterclockwise to richen up the air fuel mixture. Now the carburetor has several circuits in it also. We're going to discuss those circuits. Float bowl, idle, transfer port, main metering circuit, accelerator pump circuit, power circuit, and choke. 7 circuits, and yes, you will need to know what these circuits do. The float. Here's the float here. This is the float assembly. That's the lever for the float. The float circuit affects all. The float assembly affects all circuits. That's your first adjustment. It'll affect every circuit in that carburetor because this is where the fuel comes in at. The fuel comes in, passes this needle in the seat, and fills this bowl. Once it fills this bowl, this flow starts to rise, and it shuts off the fuel from coming in. So if you see, if the float is misadjusted, and usually adjusted by bending this tab right here, if it's adjusting and letting too much fuel in, it will run rich. If it's adjusting not letting enough fuel in, it will run lean. That's why we said the float is your very first adjustment when you take a carburetor apart and clean it and start to rebuild it. It affects every circuit. Transfer port. Now, here's a transfer port. You're going to transfer the air fuel we're going to have to transfer the fuel and air at a certain point. You see the throttle plate? This is the transfer port here. This is a slot right here. But this throttle plate, when the car is idling, this plate is closed and it's down here. So it's right here. It's like here somewhere. When the car is running, the throttle plate is closed and it's not up this high. It's like right here, and the transfer port is above the throttle plate. So when the plate is closed, it's actually running off this port here, the idle air-fuel mixture screw. You got fuel and air being mixed through this main circuit here and coming under the throttle plate. Right? They're being mixed together. The process is called should I pronounce that word? Right here, emulsified. Yeah, it's right here. Okay, emulsified. Emulsified is when you add two products together that usually don't go together. In this case, air and fuel. So this part right here, I'm gonna mix the air and fuel. Sorry, air is coming this way. Fuel is coming through this port here. We're gonna mix the two together. Air, fuel, they're gonna go down this port here. But remember, this throttle plate is closed. So at idle, in the car just sitting there, like I said, at a stop sign or in park or neutral, you ain't touching the gas pedal. The car is running off this port here. It's called this idle air-fuel mixture port. Now the transfer port is this. When you hit that gas pedal, we got to transfer from idle to off idle. So we need a little extra fuel. That's this transfer port right here. You can see I need a little bit more fuel. So as I give it gas, this throttle plate opens up. We get just a little bit more fuel. Now, if this port is clogged up, you're gonna have a drivability problem. Hesitation, slow acceleration. All right, hesitate, slow acceleration. Because we need that fuel on our takeoff. So that's our transfer port. Now I spoke about the idle air-fuel mixture screw earlier on the previous slide, but I think you can see it more here. Here's the idle mixture screw. If I want to lean out the air-fuel mixture, I'm going to turn the screw clockwise. Then we'll turn in and stop some of the fuel. That's how you lean the air-fuel mixture out. If I want to richen it up to add more fuel, I'm going to turn it counterclockwise and go this way. I let more fuel in. That's why they call it idle mixture screw adjustment. So we got air going here. We got air on top of the fuel, pressurizing it. Then we got air bleeds. I forgot to say earlier, this is an air bleed. That'll help emulsify the fuel. Okay, so this pressure on top of the fuel through another air bleed, right? It's going to push this fuel here to the low pressure area here. Because remember, when this throttle plate is closed, it's a vacuum under it. That throttle plate creates a vacuum. So it's a vacuum under it. So this fuel is going to be pushed or drawn into this low pressure area. And when I'm taking off from a stop sign, I'm just taking off, this throttle plate needs to open up. This throttle plate needs to open up. I need just a little bit extra fuel. Right? So, and that's when the throttle plate is exposed to this transfer port here. It's exposed to this transfer port. So I just get that just a little bit more fuel for that transfer from idle to off idle. And that's basically what it's doing. It's just giving a little bit more fuel when I'm going from the idle position and off idle position. Main metering circuit. Now the main metering circuit is, I like to look at this at you at cruise speeds. You're not idle, you just stepped on the gas pedal and now you're driving 45, 50 miles down the street. That's your cruise speed. That's my main, you got main metering jets, right? And most Carburetor have something called main metering jets. So, and my main metering circuit creates a low pressure area, a Venturi effect. You see this? How you got my air going through here. This is my Venturi. This is my main metering air bleed. Let me say, oh, there we go, right here. Main metering jet is right here. All right, this is the fuel bowl. It's my main metering jet. So imagine I'm going 40, 45 miles down the street. I need more fuel than I was at idle. So I got my fuel bowl, main metering jet. Fuel's being pushed this way. It's going to be mixed with the air. It's going to be mixed here because you got the air bleed. You got the fuel. It's going to be emulsified. And then I can go down this discharge nozzle, which is the main metering discharge nozzle, and spray fuel past the throttle plate into the intake to the combustion chamber. So now, this right here, this air going this way, remember, it creates some type of Venturi effect. It creates a low pressure area, a Venturi effect to mix that fuel and air either better to get down to the combustion chamber. Here's another look at it. Air bleed, discharge nozzle, here, throttle plate. My fuel going up, air going in, and they mix together. And emulsified, go out the discharge nozzle, past the throttle plate. And right here, you see this right, boost Venturi effect here. This small area, that looks like instead of going like this in the carburetor, it goes like this. This little cut like this is the Venturi, which that speeds up the air fuel mixture. Speeds everything up, like the airflow and the fuel. Help analyze it better. Here's my dog. Quiet in there. Here's the air bleeds. Here. Now the air bleeds have to be cleared. If they're not clear, you get siphoning effect, you get dripping carburetor, and the air fuel mixture obviously ain't gonna mix properly. I guess I pronounced that word, emulsified. Condition won't happen. I hope I'm pronouncing that word right. Emulsifying, something like that. But anyway, when you clean out the carburetor or servicing the carburetor, these air bleeds have to be cleared also. The rule of thumb was when we used to rebuild carburetors, if it has a hole, blow through it. Blow a cleaner through it when you have it apart. Because you ain't know if the air bleed or not. Just blow air through it. The next thing on tap is the accelerator pump. The accelerator pump job is to, let me see. Now there's going to be a little confusion, especially with the transfer port. Think about this. The transport port is a smooth transition from idle to off idle. That's your transfer port. That's where you need a little extra fuel. If you don't have it, you're gonna have a slow acceleration. Now the accelerator pump, which is kind of confusing, is basically almost the same thing. The only difference is the accelerator pump for a hard acceleration from idle to off idle. I mean, you punch it hard to take off. The accelerator pump gives out a squirt of gas really quick to get that quick acceleration, that hard acceleration. So that's the accelerator pump. So here's the lever, here's the plunger, here's the spring to bring it back, and here's the fuel that sits in the accelerator pump well. Okay? Now, when this pump is resting, this pump is up. When you hit it hard, it's going to come down. It's like a plunger, like a toilet plunger. It's going to push on this fuel. This fuel is going to be ejected through this port here. Through this port, travel out here, and be discharged through the discharge port for acceleration. Into the Venturi area, past the throttle plate, into the intake, to the cylinders. So again, the accelerator pump is for hard acceleration. It also for cold starting too. I explain that later on though. power. They have some, well, not some, all of them. Carburetors have something called a power circuit or power valve for high-speed operation. Basically means I'm on a freeway already. I need to pass a truck. I'm gonna punch it. That's your power circuit. It's just gonna dump more fuel in there. Fuel control valve into the main metering circuit. Secondary metering circuit, like secondary throttle plates. You used to love to hear that on not variable Venturi, quadra jets. You can hear when they open up. Here's some cars use a piston like this one does. When you punch it, this piston goes down, punches on this plunger to let more fuel pass the throttle plate. Here's the secondary valves. We used to call it secondary velocity valves. Right here, just call it secondary throttle valves. This right here. This is a 4-barrel. This is a 2-barrel. 1, 2. 4-barrel. 1, 2, 3, 4. These are the plates that worked most of the time. Idle, acceleration, cruising. It's just these two. And this one right here. If I punch it hard and try to pass a truck or racing somebody, you'll hear these two open up. That's a secondary valve for power. And also this one. And in some cases, they have a metering riser in there also, inside some jets. When you punch on it, and this opens up, you got 2 metering risers down there. When it opens up, it lifts the valves up out the jets to let more fuel in. Oh, crap. I had to turn that off. Private telemarketer. The choke. I said the choke earlier. Sorry, I said the accelerator pump earlier also help cold starts. It does, along with the choke. This plate right here is the choke. Understand this. A carburetor, when it's cold, and the air is much denser. Sube. Hey, Snoopy, come here. Burglar? Is there a burglar out there? You fighting crime? Huh? Are you fighting crime? Come here, get up. Get up there. Get up there. Go ahead. Want to say hi to the people? All right. I said this earlier. A cold start. Oh, I said this already. I forgot what I said. Oh yeah, when the car is cold, the air molecule is much denser. You need more fuel on a cold car. Alright? So what you need is a richer air fuel mixture. When this car is cold, this choke needs to be in its position when you first go to start the car up. As I said earlier, it works with the accelerator pump, works with the choke. This is what happens. Most people with carbureted cars, when they start their car up in the morning, they have to press the gas pedal to the floor 2 to 3 times. The accelerator pump will prime the system to get it started. That's why you hit the gas pedal 2 or 3 times to get it started a car that has a carburetor. Now, once this starts up, when you go turn the key and start it up, this choke pull-off right here, it's a choke pull-off. You see this lever right here? It's hooked up to the shaft that hooks up to the shaft head, hooks up to the choke. This choke pull-off works off a manifold vacuum. So when it starts, a manifold vacuum here is going to pull on this diaphragm inside here. It's going to pull this lever and partially open up this choke, probably 1/4 of an inch. If it doesn't, you're going to have a cold start problem or a start and dying problem. And a customer might complain, only does it when it's cold. So the choke is made to get that car started and running when it's cold. So when it's cold, when you go to start it up, this choke opens up, probably maybe a 1/4 of an inch or a little less here to let air, but mostly fuel in. That's what I got to say. It doesn't open all the way up. It's open about 1/4 of an inch or a little less to block off the air and let a little bit fuel in there. All right, that's done by the choke pull-off adjustment here. It can't be totally closed because it'll flood over and die also. But it has to let mostly fuel go in there and blocking off the air. That's why it's partially closed. As it starts to warm up, this diaphragm inside here, or this, I say diaphragm, this spring, this thermal spring in here is also hooked up to the choke through a lever going this way. Heat is coming in from this tube here. As it starts to heat up, it's going to relax and open up this choke, this choke right here. Right? It's also called a choke spring. And the reason why this is closed, I should have said this, and the reason why it's closed like this, because this choke spring is closing it. You know, you can't see, oh, you can see it right here. There's adjustments for it. The middle, there's a little adjustment right here. There's a little notch on this plate right here. So when it's cold, this spring inside is closing this. The heat right here that comes when the car starts up, heats it up and it starts to relax. And eventually when the car is totally warmed up, this choke got to be all the way open. It cannot be closed in a warm car because it runs too rich. Alright. Matter of fact, it runs so rich, if I make a vacuum leak, it'll smooth out because I'm adding more air to it. So in a warmed up car, that choke got to be open. On a cold car, this choke got to be closed when you initially started. And once it starts, the choke pull off, cracks it a little bit, about 1/4 of an inch, let air in. A little air in, and mostly fuel to go through the circuits. So this, again, if this choke was not set up correctly, you have a hard start cold or start and die cold situation on your hands. That's the choke pull off. You can see the adjustment right here. How it adjusts, you see this little slot here. You see this little lever right here? That lever connects to this choke spring inside here. That's why it's closed by that lever. By this lever right here, it connects to this choke spring. It's one thing they ain't showing you here. Also, when that choke is closed and you start it up, it's going to be on a fast idle. They don't show it here, but it's a cam gear over here that holds the idle high because it's going to be running rich in the morning time. If you had a low idle, it would stall out. So besides adjusting this choke pull off, it got also adjustment called the fast idle. And as it warms up, the fast idle cam will start to kick down and go back down the curve idle. They don't show it there. Can't see it here also. Oh, right here. You see this? That's the fast idle cam. You side up like this because the choke is closed. As this choke starts to open up, this cam is going to drop down and lower the idle. Anyway, now this is an electronic carburetor. It uses feedback solenoids. Okay, you see the solenoid right here? That's a feedback solenoid. This is the feedback solenoid that controls either, now it's kind of different on a lot of cars. Some cars just control air. Some cars just use to control fuel only. So let me back up. Some manufacturers use it to control air only. Some manufacturers use it to control air only. Did I say fuel? Some manufacturers use it to control fuel only. Some manufacturers use it to control air only. And some manufacturers like this one here use it to control air and fuel together. But this is a feedback solenoid from the computer to help balance out the air fuel mixture. It used to call it CCM, computer control. Used to call it the C3 system, computer command control. So here we got a choke pull off. You have a choke, throttle position sensor, accelerator pump here. We got an air bleed here, and metering jets that's adjustable here. You take this cover off, there's one air bleeds adjusted here also. Our fuel filter is here, and this is our solenoid, mission control solenoid. And when you rebuild this carburetor, you have to adjust, after you adjust the float, you have to adjust this metering, this idle air bleed solenoid here. And right here, this plate, this plunger, right? This is part of the solenoid here. This thing moves up and down 10 times per second. That's had to be adjusted also when you rebuilt this thing. You can't see it right here, but you got metering rods for it. It sits on top. Here's a plate, and here's the metering rods going inside a jet down here that's controlled by that solenoid. Oh, you see it much better here. Here's the mission control solenoid. Here's the plate that actually goes up and down 10 times per second. Here's the metering rods here, and there's one on this side too, under this tab here and under this tab here. All right, this is the adjustment here for air bleeds. When this solenoid, you can't see the wires, but the electrical wires to this solenoid here, and this thing's going up and down 10 times per second. And how long it stays on versus off is measured in duty cycle or dwell. Here's the TPS. Here is the accelerated pump well we talked about earlier. Here's your float. This is the fuel bowl right here. That's the float. Here's the needle and seat over here that lets the fuel in. And here's the main metering discharge nozzles. Here we talked about earlier. You can really see it now. And the accelerated pump discharge nozzles over here somewhere. You can't see it. There's two of them, one here and one over there. No, I'm sorry, I said that wrong. Not over here. That's the bowl. They in here. They up over here or over here. You can't see it. They're within inside this, inside these wells over here. This whole thing is the float bowl. Sorry, I said that wrong. And here's the feedback air control. They call it O2 feedback solenoid. We just looked at. Here's the main wells. Here's the air bleeds internally. Throttle plate, airflow mixture screw, main jets. Okay, that's the 7 circuits of the carburetor. If you have any questions, let me know. I know it's a lot, but you need to know all of them. Get back at me if you have any questions. Peace. I'm out. Hey, say bye, Snoopy. No? All right, we're going.